Good morning, ladies and gentlemen. A beam of light in air is incident into water at an angle of 42.5 degrees. What is the angle of refraction? Go.
Yep. Make a quick sketch.
Make a quick sketch. What does this look like? Okay, so we've got, beam of light into air at 42. That's going to be right around here. Right, so this is our angle of incident.
Don't forget to put the arrowhead on there.
Oh, you can see it. Oh, we can't really see it right there. Put it on this side. 42.5 degrees, and this is our incident.
So it's going from air into water. It should bend toward the normal.
Yeah, because air is 1.0003, right?
Yeah.
And then water is what is it? Look at the table. 397. Is that right? 397? Yeah, it is. 1.33. Okay, 1.33. And yeah, it should bend toward. Okay, so I'm just gonna write that here. Our little prediction. Okay, what is the angle of refraction? So I'm just.
What was that law we got to use? It's
Snell's law.
Snell's law.
Snell's law. Okay, so we're trying to figure this out. So what is it? So the index of the incident times the sine theta. Don't forget theta of the incident equal to the incident of refraction times the sine theta of the refracting ray. And we're trying to figure out this one right here. Okay.
Yep.
So should I just go through all the steps like I normally do?
Yeah.
Okay. All right. So divide by this. Okay, and then we're gonna do a sine -1.
Yeah, we don't want the sine of the angle, we want the angle.
Okay, so I'm gonna go ahead and plug this in then, the sine -1. The incident is gonna be 1.0003. Whew, I did arm machine today. I'm getting really tired. Whew, okay, sine of the angle of incident, which is 42.5. Thanks, Boykin. And then my index of refraction, excuse me, is that right there. So let's see if we can get this. Boom, 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 boom. Okay, so sine -1. Oh, that's an answer in there. Sine -1, 1.8883 sine 42.5.
Close the parentheses.
Close that parenthesis divided by 1.33, and I get 30.5.
30.5 degrees.
30.5 degrees. Does that fall in line with our prediction?
Yep, that's bending toward the normal.
Yes, it does. So this is 30.5 degrees, and we're gonna just say it goes right
Sketch it, yeah.
Okay, so that's our refracted ray. And
Sweet.
Don't forget, this is the normal. Label it all. Okay. All right. So moving on here. A little bit of review. A plane mirror is a smooth, flat surface that produces a regular reflection. We saw this with our candle demo yesterday.
Yep.
Where is it? There it is. The image produced by a plane mirror is not real. It is located behind the image, right?
Behind the mirror.
Behind the mirror. Sorry. And you have light coming in, hitting. You have a light from your foot hitting the mirror. It obeys the law of reflection, bounces off into your eye. Where do you see it? Behind the mirror on the other side.
Right, and notice that if you look down, the image appears behind the mirror because you think that light travels in a straight line.
Yes.
Now, question, do you need a floor-to-ceiling mirror to see your shoes? Would you need a mirror that goes all the way to the ground to see your shoes?
I don't think so.
Well, what does the diagram show?
It shows that you don't.
No.
Yeah.
You need a mirror that is halfway between your eyeball and your feet.
Uh-huh.
The bottom has to at least be between your eyeball, and then you'll be able to see your feet.
Yeah. It is called, and we call this image behind the mirror a virtual image because the light is not coming from the location of the image.
That's right. It's the light is coming off of the object and reflecting from the surface of the mirror. And by extending these straight lines from where the light beam comes in, that's where the image appears.
Yeah. And again, you can see light is coming, shining on her skin here.
Yeah.
Light is reflected off of here into your eye, and you see that over here.
That's right.
Now let's
Nice
talk
hairdo.
let's talk about the distance here. The distance to the image is measured from the plane mirror. Okay, the image behind the mirror, the virtual image. Same to measure the distance to the object.
It's the distance from the object to the mirror.
And so what we have is that they're equal in distance
Yep.
from that plane mirror.
Yeah.
Right? Do you have a diagram of this one?
No, well, you know,
so same distance, right? And we attempted to see that.
Yeah.
When Miss Moore did do a great job. And you know, in our lab the other day, why wasn't it as accurate? Why didn't it show the exact numbers?
Yeah.
Well, you know, I should have drawn my dots further out so I can get a longer line, less error.
Yeah.
But hey, it is what it is. What if the mirror is not flat? Can it still form an image?
Here's a mirror that's not flat,
Huh. Okay.
and I'm seeing images.
What if it's not flat? Okay, so we still see images, but let's talk about
Let's get real.
what they look like. Let's get real. Okay. Okay, so here is your lab. We're gonna start on get real. Okay, the last page here. It says remove the mirror and we're gonna use this
We're going to use this mirror over here.
giant spoon-like thing. No, I'm just kidding. Okay, remove the mirror and look at your eye while holding it at arm's length. Describe the image of yourself. Okay, so here's arm's length for me. I'm gonna go ahead and
Well, you know,
wanna do that with this
no,
one?
we're not going to do arm's
Oh.
length with this. We're just going to get back.
Oh, no, let's
and-
see. Can you? Oh no.
Well, no. Well,
Yeah?
here, I can see you.
Okay, so here I am.
I notice that you're upside down.
Yes, I am.
Now walk,
Inverted.
Yeah, inverted. Walk closer,
So are you. Okay.
and then get down, and then
Scramble. Oh, hello there. Ooh, I can hear my voice.
now you're upright.
Yeah, now I'm upright. Whoa, and I'm getting a little closer.
Okay, let me try that with a camera.
Yeah.
All right, here we are with the camera. We're going to try to keep it in the middle here. And as we get closer, upside down, getting larger and larger,
Oh, that's good.
and then
Scramble.
you get nothing. And then on the other side, now all of a sudden, we're right side up and huge.
Are you guys getting this? I hope you're getting this.
So there's
Okay.
some things going on here.
So when we're standing right here, what do we look like? Where am I?
Upside down,
We're inverted and
small.
yeah, we're kind of small. Okay. So that's our starting point here. Describe the image of yourself. Now, as we move carefully towards the mirror, what's happening to us? And go back and rewatch. We
Well,
start.
I can do it again. You get. I'll just
inverted.
be right over your shoulder here.
I'm getting bigger. I'm getting bigger. I'm getting bigger. I'm getting bigger until I get to a certain point where I look kind of like scrambled eggs.
Yeah.
All right, right there, you can't really see anything. And then once you get past that point, now I'm upright and I'm getting smaller. As you get closer into the mirror, and then I can't get okay? And I can totally hear the noise.
Yeah.
Yeah, it gets.
Well, it's a reflection. Not only is light being reflected, but sound is being reflected.
Yeah. Okay, so that is our first observation, qualitative observation we're going to be making.
Now, if you guys were here, we'd have you use the optical bench
Mm-hmm.
and set this up, but you're not.
Yeah, instead we did the heavy lifting.
All right, so
Okay, so for this lab, we're going to be using parts from both these boxes. And let's see, so we put together the rail here,
yep,
and then we stuck the this
experimental lamp.
experimental lamp, thank you, Wicked, on here. Now this is the source of the light. And we have our object right here.
Yeah, pull that out and show them what we got.
Okay, we have an L. L because we love physics. Okay. Love, baby. And then we have our mirror. Now, it is a concave mirror.
Just like that big one over there, except smaller.
It's a cave. It kind of goes in, right? And then we have a projector screen over here.
Yeah.
Okay. And what are we going to do? We're going to turn the light on. And we have this L with the light shining through it right here. And we've got our mirror here. So
It's going to bounce off the mirror, and then we're going to try to shine it on that screen down there.
yeah, and let's look at the data, the type of data we're going to be collecting. So we're going to be changing the distance of the distance that the object is from the mirror. So we're going to be
Object
moving.
is the letter L.
Yeah, object is letter L, and we're going to be moving this back 15, 20, and then 30. And we're gonna go ahead and measure the distance that the image shows up on the screen
Yeah.
As we move it.
Yeah.
Okay.
And it's going to be kind of hard to do. This would be a group of 4 people with
Yes.
many hands to help. So we'll see how we can do this.
Ms. Moore and Mr. Boykin we're gonna do the best we can.
All right. First of all, show them how to measure the distance
Okay.
between.
So,
Now, it's the distance from the object to the mirror.
so the object is our L right here, right? And we're gonna measure to the mirror. The mirror starts at about the second notch
so
right
put
there.
15 right
Oh yeah,
here.
yeah, that's what we talked about. So we put our 15 right there, so that 15 lines up with that part. And let me go ahead and move it back here so I can line it up. And you see how that tick mark is right there at that.
Okay, and that
spot right
because the
there.
mirror is down inside, it's not right at the front.
Yeah, exactly.
All right, let's make it dark in here.
Okay, let's do it. All right, so
Now you go ahead and start in close.
that's right. We'll close
'Cause
it.
you have-
Oh, there we
okay.
go. There's our light. Okay, so clear yet? No. Okay,
Yeah.
we're gonna stop once it gets sharp. Okay.
Looks pretty good right there.
Right here.
Yeah, okay, I got 1 meter here.
One meter there. Okay, we're gonna go right there. We'll call it 1.3 meters.
1.3 meters.
Okay, so I'm gonna go ahead and write that right here. Oh, you know what?
Or 150
Oh yeah.
centimeters. We could use, yeah, it'd be 130 centimeters.
130, right?
Yeah, 130
With our mental
centimeters. And you know, the standard unit, we don't have to use meters.
We forgot to describe the image size, larger,
Oh.
smaller, same. Okay.
Well, this is the object, it's the letter L right there.
This is big.
It's bigger and it's upside down.
Yeah, it is upside down. Now, do we need to measure the height of it, Boykin?
We could.
Okay. I should put my hair back today. Okay. So, where's my centimeters at? Well, this is really hard to do with just two.
I know.
Okay, I'm gonna call it 13 centimeters. I think it's a little bit taller than the thing shows. Okay, so 13. That's kind of funny. 13 centimeters. Okay. Whew. All right. So now, next step. Oh yeah, and it's also inverted. I'm gonna add that.
Upside down, inverted. Inverted is a technical term. Upside down is probably the one that's easiest to understand.
Yeah. So upside down.
Yeah.
Okay. Now for the 20 centimeters, let's go ahead and put the 20. Where are we at here? 20. Oops. So 20 right there.
So see, we're changing the distance between the object, the letter L, and the mirror.
Right there is good.
Okay, you want
Wrong
it from
way.
I'd use it from the center here.
Oh, did I not measure it from the center there? Let me double check. So that's good. Oh, from the center right there. 20. Oh, yeah, okay, move a little far. Right there.
Good.
Boom.
Okay, 20 centimeters.
All right. Let's do it. All right, so look at that little guy. Oh, okay, blurry, crisp, blurry.
And you can probably just set it down there, can't
Yeah, I can here. Make
you? And move
more.
it back and forth. That'll make it much easier to.
measure.
Now, what she's doing is she's focusing right now. She's moving. Why don't you move forward and show them what happens to the image?
Oh, move forward, yeah.
Yeah, move close.
A little blurry.
Closer, 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 closer.
Yeah.
Blurry, okay.
Ball of
and then,
light.
Then you go back, 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 blurry, blurry, blurry. So there's one spot where it comes into focus.
I'm gonna say it's right there.
Yeah.
Okay. So here we go.
Can you still see the? Oh, let me turn one light on.
Yeah, I can see it there.
we're measuring the distance from the lens to the mirror, and that's about 45 centimeters.
45, baby. So yeah, 45 centimeters, sorry.
And that L is much smaller than the previous one. Let's measure how tall it is.
It's a lot smaller, but it's also still upside down, right?
It's still inverted.
Call it 3.
3 centimeters? Sure.
Okay, 3 centimeters, and yes, it's still upside down. Upside down. Or inverted, whichever you prefer. Okay, so now we are gonna move back a bit here.
So we started off with the lens, I beg your pardon, with the mirror close to the object.
Come on.
And now we're gonna be at how much?
30.
30 centimeters.
So right there at the end here. Right there.
That looks good. Okay, let me turn the light off.
Okay. And here we go. Oh.
Just blurry when you're too close and blurry when you're too far.
I'm gonna say right there.
Yeah, I think so.
Okay, I might be able to use this guy. Yes. All right. Okay. So, here we go. Call it
25, 20.
25, yeah. 25 centimeters. Okay, and now let's measure the height of this little cutie.
I noticed that the L is smaller.
It's definitely smaller. Let's call it 1
centimeter?
1 centimeter. And still upside down, right?
Yeah.
Okay. So that's it. Now, Boykin, I remember when we did this before, we walked outside.
Well,
Do we want to do
let's
that with
turn
them?
the light off.
Yeah.
And, well, it's on the back. It's the next thing. It's
Oh,
on
is
the
it?
back.
Okay. All right, so let's take a look at our numbers real quick. Or,
Yeah.
yeah? Okay, so what do we notice? We notice that as we move our mirror further and further out, what is happening to our image?
Well, when the mirror was close to the object, the image was way off the table.
Yeah, when it was up here, right? It was way over here. And as we move back,
The image came in.
it came in like this.
Yep.
Okay. Now, is this a real or a virtual image?
Well, by definition, we haven't talked about it yet, but if you can project it on a screen, it is a real image.
Yes. Okay. Now, let's go and move this back section here. Bada boom.
What I'm going to do is move this over.
Oh, we need this though.
Yeah.
Okay, so turn the concave mirror toward the door. Okay. Move the screen to see if you can catch the image of the doorway. What is the distance to the image?
Okay, so what you want to do is you want to put the screen, you don't want to block the door, you want it off to the side just a little bit.
I can see something there, right? You know?
Yeah, and then go back and forth. And there is the image of the outside.
All right, you ready?
Oh, there's Ms. Marr. Walk back and forth.
Okay, here we go.
One way, there's the other way. That is a real image right there. Good job. So she walks back and forth.
Now, were you able to see? So I was inverted, right? Now, did you catch what happened as I walked from
Yeah.
left to right? Right.
Yeah.
I was going the opposite direction.
Well, you tell me, take a look.
Yeah.
Now I'm going from right to left. What direction am I going? I'm going from left to right. What direction am I going?
Well, for me, you're going as you go. It's hard to explain it.
Well, let's take a look here.
Yeah.
In the image, the door is on the left, and in the real world, the object, the door is on the right. So she's You do that again. Okay, oh yeah, it's reversed.
Reversed.
It's reversed. Yeah, walk past. It's reversed and upside down. Cool.
Cool. Okay. So these are the things.
Okay, don't move it. Now we need to measure the distance from the screen. And you know what? Let me get a better ruler.
What is the distance to the edge?
This ruler has 0 closer to the end.
Here we go. All right, so we'll go like this. It's hard to get it lined up.
Well, put 0 against the screen.
Oh, 0 against the screen. Oh, yes, I like that idea. Okay, so 0's right here. Let's
call that about
12.5.
Sure, 12.5 centimeters.
Yep,
Yeah, I wish you would.
Okay, 12.5 centimeters. Okay.
See what we got right here, Sue? We have an image of the doorway out there.
Oh, cool. You just walked through our image. Sorry.
Hey, Miss Fox.
Okay, so move the screen to see. We did this. What is the distance to the image? 12.5 centimeters.
Right now.
Cool. Okay. All right, so we're done with that, yes?
I think we're done.
Okay. Sweet. Okay, so you guys have all of your data written down, all your data collected. You've finished up. You've described what happens here. Are we done, Boykin?
We're done with this.
I think we are. Okay.